Now, nuclear fusion is different from fission. Now, with fission, it's dividing, okay? And with fusion, it's putting it together. So, fuse energy drinks, for example, is an example of when they put two different things together, they fuse them together to create something else. Okay? Now, the benefits of using nuclear fission is that it is a renewable resource. And it also reduces carbon. So those are really good things that we have. Unfortunately, it is very expensive to start up. So that is definitely an issue. And getting rid of waste. When you have to get rid of the waste, it takes you have to monitor. So basically, after you've gotten everything that you wanted out of it, you have to actually monitor it for up to 10,000 years. It could still be nuclear. The impact, there's always impact or opportunities for disaster. And we have had some of those disasters with nuclear energy. One of the ones you may have not heard about is Chernobyl. That was one, and you guys might want to look that up, watch the video for that one. But it says the one that happened in your lifetime, the Fukushima, Japan, is actually one of the worst ones that happened. And I think that one is recorded as one of the worst ones in history. So actually both of those are. So you're going to watch a video on that on your own time at another time. In North Carolina, 30% of the electricity comes from nuclear plants. Okay, they are located in the Piedmont and the coastal. So let's see if we can pull back up our map. Doesn't look like we can. That's okay. Just remember where the Piedmont and coastal regions were. When we talk about nuclear disasters, we typically use the term nuclear meltdown. So here's a quick recap that was after the disaster in Japan. Had to look at the date of this one again, and they'll explain to you a little bit about what does it mean to have a nuclear meltdown.
The government now says 2 reactors are in partial meltdown and 4 more are at risk. They're warning that another explosion similar to the one we saw yesterday could be imminent. They say they're doing everything they can to contain the damage before any radiation is released. But 170,000 people have been evacuated from those areas around the facilities. Now, I want to say the word meltdown is being used a lot these days. It is a loaded and scary term, so we want to be absolutely clear about what it actually means. Ron Claiborne is here with a quick explanation of what exactly happens when a nuclear reactor melts down. Ron?
All right, Dan, let's start with a simple graphic of a nuclear reactor. Now, normally, the uranium core, the potentially dangerous part of the plant, is immersed in a coolant. That is usually water. That coolant is constantly being pumped in and out to keep the core cool. When the earthquake struck in Japan, those pumps went down. The uranium core then had nothing to keep it cool, so it began heating up, boiling off that water. And if that water eventually boils away, it exposes the core, and that's when the real trouble starts. Once the temperature inside reaches 5,000 degrees, that's when you begin to have the meltdown. If the unstable uranium is disturbed in any way, it explodes, bursting through the vessel that contains it, releasing dangerous radioactive particles into the air, and that is the worst-case scenario there that many fear could happen in Japan.
One more thing about nuclear fusion is that the rate at which the speed you have to get these atoms together is a very high speed, and that's another thing that could cause some damage. All right, we're going to move on. Whoopsie guys, me and this computer are not being great fans right now. Okay, hold on. Now, wave power is using the water. Okay, I guess that's the real place where you have waves, other than radio waves. But it's beneficial to North Carolina because it's renewable and it's constant. So the ocean waves are always coming. Okay, larger pool waves are always coming. And remember what we talked about. Waves can be in any large body of water. So if you have a large lake, you can have waves as well. We only really think about tides and waves referring to the ocean, but the tides and waves can be in any large body of water. So it is some downplays or some downsides is it's a high startup cost and it has lots of regulations. Because remember, technically nobody owns the ocean. So the state has to put down some regulations to ensure that at least the environment is safe. It is damaging to fish and wildlife, which means you have to create some kind of barriers in between. Think about when dams are built. And there is a separation in the water, basically. And you have some things on one side and some things on the other. So it could disturb their natural, it will disturb their natural habitat. North Carolina, if we use it, it is on the coast of North Carolina, because since we are on the ocean side, the Atlantic Ocean, that's going to be our best bet. If we don't have, it has potential. Notice it says potential, which means this is something we're really not using much of at this point, and really don't have a good startup of it. Now I'm going to say, you guys watch that video on your own. It is related to North Carolina, but I'm going to move on. To the last thing, geothermal. So with geothermal energy, geothermal, geo means earth, thermal means heat, so you're looking for heat from the earth. Now it's beneficial because it's renewable and there's no carbon added to it, so that lack of pollution, has no pollution. Again, when it comes to cost, it's a high startup cost to get that going, but it is clean for the environment because, again, you're just taking energy straight from the environment. Now, North Carolina does not have this. In order to use geothermal heat in North Carolina, you have to have tectonic plates. Okay? Now we're thinking, well, at the mountains, we have mountains, so therefore if we have mountains, we have to have tectonic plates if we have those. Again, though, the issue becomes it has to be near a plate boundary, and we do not have access to that. All right, ladies and gents, these are some videos, again, to watch on your own at some point right now for a little added information. But for this video, for right now, that is all, video lesson, that is all I am showing you. Again, videos on your own.